Hello, am I audible? Hello. Okay, so shall we start a session? Okay, so are you all excited? I would like this session to be a two-way interaction, so please respond, guys. Are you all excited? Yeah, I can see a lot of yes on chat box. Okay, so hola amigos, a very warm welcome to all of you to WLG's very own informative podcast, that is the FOSS files. This is our season 6, that is CDN Mystery, and I am your host Rishi Oswal, welcoming you all to the very second episode of this session named CDN Dynamics. So, before we finally deep dive into the agendas of today's episode, uh, let's have some questions. So, how many of you attended the previous episode? Yep, I like the excitement. So, could anyone tell me the name of our previous episode, the very first one? You may answer by unmuting yourself or just dropping your answer in the chat box. The name of our previous episode. Okay. Yes, yes, I can see the answers. Yeah, very well. So the episode's name was Networking Essentials. So now some question regarding the previous episode. So could anyone tell me the topics that we covered in the previous episode? Like what was the previous episode about? You can also unmute yourself to answer. Yeah, Harshit, Siddharth, Neil.
ते अकॅडमीचं कसं म्हणतोय मी संस्कार सांगितलं का तुला माझं काय म्हणणं आहे त्या अकॅडमीचं
Raj, your mic is on. Would you like to answer? Yeah. Okay. Yeah. So those are the topics like introduction to computer network, networking devices, the protocols related to networking, and finally the introduction to CDN. Now, can anybody explain to me what is CDN and what does it stand for, or what is the basic definition of CDN? Yeah, yeah. So CDN stands for Content Delivery Network. And could anybody tell me the basic definition? Guys, you may answer by unmuting yourself. Yeah, so how data center are decentralized for efficient. Yes. Yeah, that's the perfect definition. Anybody else would like to try? Yep. collection of global network used for faster delivery of data. Network of servers distributed across different locations. Yes, that's on point, Varad. Yeah. Yeah, so I can see many correct answers. Yeah, so that is all about CDN. So are you all excited for the second episode? Yep. So for our new viewers, I would like to give the overview of our podcast. So basically, FOSS File is the podcast of WLEG, that is Walchan Linux Users Group. We cover one major topic every season, and this year we have the topic CDN, that is Content Delivery Network. We'll uncover all the concepts, the terms, and terminologies related to the topic. So, which will be important to lay a foundation for your future as well. So, wake up everyone if anyone is sleeping, and we are about to start the knowledge booster session. So, please try and stay attentive. You will get to learn a lot about CDN. So, this was all from my side. Now, I'd like to hand over the episode to the speakers of today's session, that is Huma Naz Mohammad Didi and Ashutosh Shinganvaya. So, that was all from my side. I'll hand over the session to you.
Hello, everybody. So, before we dive into our topics for the day, we were discussing in the last episode, we were discussing what are the different types of CDNs. So, can somebody elaborate on that? I would love to see how much you guys have learned from the previous session. Okay, I see a few people typing. Yes, I see a lot of people answering private, public, peer to peer, push CDN. Full CDN, correct. So, the reason why I asked that is because it's going to be an integral part of today's session. So let's see what are the topics that we're going to be covering today. We're going to be covering public CDNs and caching. So before we move forward, let me ask you all something. How many of you have experienced this? When you are opening the MHCET website to check your results after the CET test, did you notice that the website was lagging, was it slow, or just completely crashed? Because so many people were accessing it at the same time? Yes, okay, I see a lot of people have similar experiences. But when you contrast it with with a website like Amazon during a flash sale, do you ever see those websites lagging or crashing out completely? Not really, right? So the reason and the secret behind this relies on the infrastructure, that is the CDNs. Let's understand how that works. So, from previous session, can somebody tell me what public CDNs are? Third party providers, correct? Anybody else? Okay, so a public CDN is a third party provider that provides content delivery infrastructure to any website or application that wants to use it. So that is the general purpose of a CDN, that it provides content on a global level. And the unique thing about the public CDNs are that it's available to general users. Whereas if you contrast it with private CDNs, they're only available to people of a certain organization. So, some of the examples of public CDNs are Cloudflare, JS Deliver, and CDN.js. So out of these, JS Deliver and CDN.js are open source CDNs. So now let's look at some of the key features that are provided by a public CDN. They provide global content delivery, which means that they deliver content to all parts of the world, be it India, US, Europe, anywhere, right? Secondly, it's easy to use and quick to set up. So why is that so? Because since we're using a third-party provider, we already have the infrastructure that we need, and we just need to ask the provider to set it up. So for example, I have a portfolio website, which I want recruiters across India to be able to see. So I want to set up content delivery nodes all throughout India, maybe in Sangli, Mumbai, Karnataka, Odisha. So our content delivery provider will already have these servers, and we just need to ask it to set it up. Now, it's cost effective and scalable. Well, how so? Well, public CDNs are usually free or follow a pay as you go model. Now, what does that mean? That means that you only pay for how much ever you use. Now, they also have built in performance metrics and security features. Some of the security features, like DDoS attacks, we have discussed in the previous session, and we'll also discuss this more ahead. Now we've discussed what public CDNs are, what public CDNs are, and what are the major features. Now let's see, when should you use public CDN? So coming back to your portfolio, so maybe you coded it using HTML, CSS, JS, or maybe React. So host open source libraries like jQuery, we can use CDN.js. Or in order to deliver your images, maybe you're showcasing your projects and the awards that you've gotten on your portfolio, then you can use an image hosting. You can host these images with a CDN, for example, AWS CloudFront. Or you're showcasing your code that you've written, and you want to show the code through GitHub, you can use JS Deliver to deliver these open source files. Image hosting. You can I think somebody's mic is on. Please mute it. Ronald, please mute your mic. So now, while we see when we can use public CDNs, it's important to note when not to use it. So here, I would just like to add a note. Even though I'm saying that we can't, it's not that we can't use public CDNs here. We just need to be more careful. So what are these scenarios? When you're handling sensitive content, for example, your banking information or somebody's healthcare records, you want to be careful what information you're putting on a third-party provider. Or when you need complete control. So since you're using a third-party CDN provider, you will not have complete control. Thus, in these situations, you might want to use other types of CDNs, maybe private CDNs or host your own. But you are able to use public CDNs in these scenarios as well. You just need to be more careful. Now moving on, we've seen what public CDNs are. we've gotten a broad ideas of CDNs, but let's dive into how this actually works internally. That is their architecture. So there are four main pillars: the origin server, the CDN provider, edge servers, and the DNS routing system. So each and every pillar plays an integral part. Let's know more about them one by one. So, firstly, the origin server. So, this is often known as the source of truth. Now, why is it known as the source of truth? This is because it always has the latest version of all the data or files. And any updates that you make will be reflected on this server first. So, to understand this, let's go back to our portfolio example. Imagine that you're hosting your portfolio website using your laptop as your origin server. So, all the content that may be your HTML, CSS, and JS files, they will be on your laptop. That is your origin server. And any changes you make to the code will be first reflected on your origin server. Any other component of the CDN only receives temporary copies of these files. So it stores data, sends content to CDN when there's a cache miss. This we will understand in detail later. Handles dynamic requests. This again we will be delving into in exactly how this happens in a few minutes. So now moving on to our next pillar, that is our CDN provider. This is our third party provider that is actually going to provide us with the infrastructure. So this maintains our edge servers that are going to be in different places. So if we're considering our portfolio, the edge since we're focusing on India now, the edge servers will be in different locations of India, like Pune, Sangli, Karnataka, and it offers protection like DDoS protection, caching rules, and edge logic. So how does it provide DDoS protection? This we will understand a little later. Moving on to our third pillar, edge server. So your edge server stores copies of your content from the origin server that it borrows from the origin server and serves user in the nearest geographical location. So what does that mean? For example, I'm a user in Jharkhand trying to access a file. I can access the file through a server in Bihar because it's closer rather than a server in Pune. Doing so will help us increase the speed and reduce load on the origin. How does this reduce load on the origin? Since every request does not need to go to your origin server, it can go to your edge server and directly get the data from there if it is present in the cache. Now, here I would like all of you to note that this also increases security as a request has to go through. This is important. It has to go through an edge server. It cannot directly go to your origin. Now, coming to our fourth and final pillar, the DNS routing system. So, can anybody tell me the full form of DNS? I'm sure all of us might know this. I see a few people typing. Domain name system. Yes, a third. Okay, so let's see how this system works. So, the routing system is basically used to connect your request to the best possible edge server. So, it's not compulsory that always the nearest edge server is going to be your best performing edge server. Now, why so? So this depends on various parameters like load on the server, the latency, and location. So if this we can understand actually through an example that we took in our episode 1. So you remember that it was Taxi's Christmas bash, right? Everybody remembers this analogy? Yes, okay. I'm glad you all remember. So let me explain the basic premise of it first. First, a taxi wanted to host a Christmas bash. For it, it wanted to bake a cake. Now, ordering the ingredients from Amazon would have taken 2 to 3 days since the main warehouse is in Kolhapur. So, taxi decides to order from Blinkit so that it can get the materials within 10 to 15 minutes. Right? In this case, Kolhapur warehouse acts as an origin server, and the other smaller warehouses, like in Vishrambagh, Miras, Karar, act like edge servers. So now, sir, can anybody tell me what does Blinkit act as? Which pillar is it? CDN, yes, correct. So now, when the DNS routing system wants to choose which warehouse to get the ingredients from, it can check out Vishrambagh, Miras, or Karad. But let's say that the Vishrambagh server has a lot of hold up. There are a lot of orders that still need to be processed. In that case, you will go to Miraj warehouse since it's still relatively closer and does not have as much load so that it can process our order faster. That is what a DNS routing system does. It guides you to your nearest, most optimal edge server. Now, these were very simple examples, right? Like a portfolio with only static data or linked system. But now let's see how the CDN system would work all together when we're working on an e-commerce website like Amazon. I'm sure we've all used Amazon. So these kinds of websites have two kinds of data: static data and dynamic data. So static data is going to look the same for everybody. So this can be the product images, product specifications, right? As dynamic data is going to be unique to the user. What are these? Like your cart, your personalized recommendations. So dynamic data keeps on changing based on the context. Let's see how our system is going to handle these two different types of requests. So imagine you hop onto Amazon's website. There you want to log in. So there will be two kinds of data. First, when you open the login page, the HTML, CSS, JS, the front end of the website is going to be the same, correct? For everybody. So that is going to be your static data. So in order to get your static data, the user will send a request for the login page. The request, when it will reach the CDN, the DNS routing system will find the best performing edge server to satisfy that request. So now that we've reached an edge server, it will check whether it has the data. If it does, it will send it back. So the static data can be handled directly to the edge servers. But when you enter your login credentials, for example, your username and password, this is going to be unique for every user. This has to be verified by the origin. So we send the request to the origin server through the edge. And then the origin server will reply with the result, for example, successful login or login failed, which will be routed back to the edge server and then finally back to the user. So here it's also important to note that we can see the separation. User's request will never go to the origin server directly. It will always go to the CDN. So till now, we've covered public CDNs and their architecture. But I'm still unclear on how my CDN is communicating static data. So, in order to clear this up, we'll be learning about caching. I'm sure a lot of you here know caching. Can somebody tell me what it is? Temporary stores data, yes. So, caching is basically the process of storing your frequently accessed data for faster access. Right? It stores it in a temporary storage location so that these files can be accessed quickly. So we all encounter caching on a daily basis, like our computers, where our CPUs store frequently accessed instructions in cache for quick access, or our browser cache, which stores assets locally. Now, a very good example of this that I'm sure a lot of us have encountered on a daily basis can be through lead code. So, how many of you solve questions every day on lead code? Okay, I'm seeing no responses. Nobody solves questions, guys. Okay, no worries, not daily. Cool. But everybody's familiar with lead code, right? Good. Okay. So, when you type up a solution in the code editor for a problem and you accidentally close the window, and you reopen it, is your code present or gone? It's present, right? But similarly, when you open a question that you might have solved a few months ago, will the code be still present in the editor? Not really, right? So this is because of caching. So it stores or typed up code in the cache for a fixed amount of time. So now, if we talk about a real world example of this, it can be a few messes that you create. Maybe you keep your clothes on your bed or your chair for convenience, right? You want speed. So the next time your mom shouts at you to clean up your bed, you can explain to her that it's for optimizing your process and for speed. Terms and conditions apply, guys. Don't blame me later. Now that we've understood caching in a general sense, let's see what it does when it comes to CDNs. So, when we talk about caching in CDNs, it is the process of storing website content on global edge servers. So, while we were talking about caching and the examples, we were talking about personal examples, like on your laptop or on a website in your browser. But when we talk about caching in CDN, it happens to a global range of users. So maybe all users in Pune. Their frequently accessed content is saved on an edge server for a fixed amount of time. Now, how this happens and how we decide how much time we need to fix it on, we'll get into that. So, don't worry too much about this diagram right now. We'll understand it in detail after we understand a few basic topics about caching. So, firstly, let's talk about HTTP headers. So, what are these? They're metadata attached to every request and response. Do you guys know what metadata is? Data about data, right? So, they basically describe who is sending the request, what the client wants, how the server should respond. Basically, a set of instructions. So, when we try to relate this in terms of CDN, what does this tell us? It tells us whether we want to cache a response. If we do, then for how long? When do we want to purge it? How to serve it? Is there some compression algorithm that we're going to be using? So, in order to do this, there are specific headers and fields. So, now sends these headers. These headers are sent by the origin server to the edge server. Because, as we discussed, what is the origin? Somebody answer? Main server, yes. Your source of truth. So all your original content is going to be stored in your origin server primarily and is going to be borrowed by these edge servers. And they have temporary copies. So when these edge servers get their copies from the origin server, that is when HTTP headers tell them how long to cache it for, whether to cache it at all. Let's look at some of the headers. So one of the headers is cache control. So this tells us if we want to cache the content, for how long, and whether it needs to revalidate it. So I've put up some examples in the PPT. Cache control, public must revalidate. So public denotes that we want to store this in the cache. And revalidate means that whenever this is accessed from the cache, it must be revalidated with the origin. The second one tells us max age. This max age is equal to 3600 seconds. This is always in seconds, and it will tell us for how long we want to store it. And the third one tells no store, which means, as the name denotes, that we do not want to store this response in the cache. This was just one of the headers. There are so many more headers, like expires, which tells us when this cache will expire, last modified, that will tell us when this was last modified, when the response was modified before, the content encoding type like gzip, content type, whether it's a video, an image, a WebP, the authorization. I'm sure if a lot of you must have made a login sign up page, you use JW2 tokens, right? And in order to verify them, you check in the headers with the token. This is where it is actually stored. Now moving on to our next concept, cache hit and cache miss. So when a request is sent by the user to the CDN, DNS routing system will route it to your nearest and most optimal edge server. Now, if your data is present in the cache of that edge server, it will result in a cache hit. But if it's not, it will result in a cache miss. Now, what do you think will happen once a cache miss occurs? Do you think we're just going to leave it and just send a response ki sorry user, we couldn't find it? No, right? So let's see what happens. Yes, correct. It will request from the origin center. So first, user A is requesting some content. When user A does so, it will go to its nearest edge server through the DNS routing system. Right? Then the edge server will check whether it's present in its cache. When a cache miss occurs, that request will be forwarded to the origin to get the content from the origin and store it in your cache. Now, this will be dependent on the headers. But if the headers allow it, it will be stored in the cache and the response will be fed back to the user. Now, assume user B requests for the same content. Then you'll go to your nearest edge server and a cache hit will occur since the data is already present. This response will now be given back to the user. So I hope that this is clear. Going forward, we'll be delving into some of the more advanced caching techniques like tiered caching and dynamic based content based caching. So let's talk about tiered caching. Now, what did we learn? When a request is sent, can somebody tell me the process? Well, when a request is sent to the CDN, will route the request to the edge server. Guys, come on, quick responses. DNS, correct. Now, what will happen next? We will check if the data is present in the cache or not. So if it is present, what will happen? Will it go back, the response go back to the user or will we go to the origin? User, correct. But if the data is not found, then what will happen? Will we go to the origin or user? Origin. Okay, very good. So I think all of you have understood the basic flow. So now, when we introduce tiered caching, we introduce multiple layers. Here, the data is not present on your edge server. Instead of going directly to the origin, we will first go to your regional server. If it's not present in your regional server either, only then will we go to your origin server. So how will this help? Less load on your origin, right? Because not every cache miss is going to your origin. It will first check your regional server. So in order to understand regional server, let's take the example of Amazon, a global website used by everybody across the world, right? So it must have regional servers for each continent, edge servers for the countries in the continent. So for example, Asia will be the regional server of India, China, Japan, right? Another advantage will be the security. And how so? This will be because there are multiple layers before the request reaches the origin. And this will also be helpful against DDoS attacks as we will have more infrastructure and more servers to not get overloaded by these attacks and then we will be able to absorb it. It will also increase speed because for every cache miss, we don't have to go back to the origin. We can just go to our regional server, which will be much quicker, right? So to understand this, let's come back to our graphical example. When we were talking about, let's come back to Amazon only. You search up a laptop on Amazon. So maybe you're searching for Acer Nitro 5, okay? You send the request, it goes to your CDN, and then the DNS routing system will route it to your nearest edge server. Now, when you open the edge server will check if the data about acyl nitrophyll is present. If it's not, it will go to the regional server. If it's not present in the regional server either, only then will it go to your origin server. Like so. And then your data will again follow the same sequence back from the origin server to the regional server, from the regional server back to your edge server, and then finally back to your user. So now it's important to note that here we're not interacting with other edge servers. We're directly interacting with our regional server. And this regional server will contain the most accessed files in that region. So that was it for tiered caching. Moving on to dynamic content-based caching. So dynamic content, as we discussed earlier, is content that changes based on your context or personal information like your personal cart, your personalized recommendations, and all of that stuff. So, as in the example that we discussed earlier with your login credentials, that is something that cannot be saved. It has to go to the origin to be verified. But when we talk about flash deals, like for example, if we talk about Instagram, right, your feed changes. The feed will be somewhat similar for people in the same area, right? So this dynamic data can be saved using a few smart rules. Let's see what these smart rules can be. And the major advantage of using dynamic content-based caching is again that we reduce the load on the origin and that not all requests have to go to the origin. This also increases security. Are not going to the origin time and time again. So coming back to our special rules, we need to check parameters, create cache keys, create cache buckets. But this feels very broad, and we don't really understand anything by just stating these rules. So let's see what each of it really means. We need to check parameters. So here, for example, we need to check parameters like what is the device you're accessing this website on. So when we're talking about Instagram feed, you're accessing it on your phone or your laptop, your tab. Right? What operating system are you using? Are you using Linux? Are you using Linux is not an operating system, guys. It's a kernel. Are you using a Linux-based operating system? Maybe Ubuntu, or are you using iOS, Windows? Another parameter can be the location that you're accessing it from. India, Nepal, Sri Lanka, or your URL path that you're working. So using these parameters, we create a cache key. A cache key is going to be a unique identifier. That is, it groups parameters to form a unique identifier that can then be accessed. So how can they be accessed? So here we can see an example of a cache key being your feed, that is your URL, and your location that I'm accessing it from India on my phone, right? So now, using these cache keys, we form cache buckets. These buckets are storage slots for each key. So they will store your specific data for a limited amount of time. This specific data, that is for global users in India, need information because this will be relatively similar, correct? Even though it's dynamic and is going to be changing quite a lot. So now it's important to these cache buckets are going to be automatically created by the CDN, and your developers only need to configure rules about which parameters to include or not include in the cache key. So let's see how it actually works. So first, your CDN will check your parameters, then create buckets. For example, here we created 2 buckets like feed for mobile users in India, and second, feed for desktop users in the US. Now, as you can see, the data for both of these will be drastically different. Firstly, why? Because they're accessing on different devices. One is on mobile, one is on desktop. How will this make a difference? Because you don't want your mobile UI to be going to your desktop UI. That will just look messed up, and vice versa either. So, that is an important distinction. And content will be different for Indian users and US users. Right? It is based on your algorithm, what you frequently access. So that's going to be very different. Now it stores responses for very short durations, like 10 seconds, 30 seconds. Now why is so? Because this is very data that is subject to change very easily. We want to be sure that it is getting updated frequently. So here, let's see an example. So for example, where a mobile user that's searching up deals on Instagram in India. So when this request reaches an edge server through a DNS routing system, it will check whether the content is there present in the cache. If it is not, then it will create your cache bucket, it will check your parameters, create your cache key, and create your cache buckets, and then in your cache it's not present, it will go to the origin server and request the required content. Once the required content is fetched from the origin, it will save this content in your edge server in the specific bucket and then give the response back to the user A. Now, your user B, within the span that the content is being stored for, maybe 30 seconds, the user B has requested for the same content after 5 seconds. Then it will reach your edge server, a cache hit will occur for the same cache key, it will find the bucket, and this response will be returned back to the user from the cache directly. But now, what do you think will happen when we've passed our window? Maybe 30 seconds are over. User B has started requesting after 35 seconds. Do you think we'll get the data, or will we have to go back to the origin? What do you guys think? So, in order to solve this problem, it is not really a problem, but we can make it faster for cases like Instagram, where our data is not, where there's not really a very big problem if our data is a little bit older. Right. So, in order to solve the scenario that I just mentioned, where what if our data has just expired? Then CDNs can also serve expired content instantly while simultaneously fetching fresh content in the background. What does this mean? For example, you requested for the same content after 35 seconds. The window was for 30 seconds. But here, as we can see in the header, stale while revalidate is equal to 90. So what does this denote? This denotes that how long can I use this expired data to give a response. So that was 90 seconds. So we're still at the 35-second mark, right? So we can still use it. So we serve this data to the user while simultaneously we go to the origin, get fresh data from there, and then once we have it, we update the user and we give them the fresh data. Now, it's important to note when we can and when we can't use this. If we talk about very sensitive platforms like a trading platform, we cannot afford to give them data that is even slightly old. So, in those scenarios, we do not use it. But when we talk about Instagram, even if we see our feed that is 5 seconds to stale, it's not an issue. So here we can see a sample flow. You've opened Instagram on your laptop and you're searching for deals. So you request dynamic data to the CDN. The CDN creates, checks the parameters, creates the cache key, checks if the bucket exists. So now it found that the bucket existed, but the response was stale. But since we were still in the window of stale while revalidate, we sent that stale response back to the user. While simultaneously, the CDN requested the origin server for fresh content. This fresh content, once received by the CDN, was stored in the cache, and then the fresh content was updated on the user interface. So now another fun concept is negative caching. So negative caching refers to catching error responses. So these error responses can be like 404 that we're all familiar with, not found. When these types of responses occur, first again, what will the flow be? We'll go to the edge server first. So if a 404 exists, obviously the response will not be found on our edge server and it will have to go to the origin. When we go to the origin and it returns a error code like 404, 403, 500, then these responses will be cached on our edge server. Now, why are we going to store errors, right? Well, this is so that your origin doesn't get overloaded and it doesn't get hit repeatedly because of the same bad request. But it's also important to note that the amount of time that we're storing the content, this cached error response for, is a very short duration since our origin server is our source of truth and we want this source of truth to be this is where the latest updates will be reflected and we want the error to be sorted out as fast as possible. So if there are any changes, we want it to be reflected quickly in our cache. So that is why it has a very short time to live. I hope you guys have all understood. So in this case, I would like to warn you that the next time you get a 404 response or an error response, don't start smashing your computers. You need to wait for 30 seconds or so until your cache response is gone. Otherwise, you'll just be getting cache responses, right? Next, let's look at the flow in detail. So first, you requested some content. This content was not present on your edge server. So it went to your origin server to fetch it. Now, on the origin server also, you get an error response. Now the error response is cached and that response is delivered to the user A. Now, when user B requests for that same content to the same edge server, we will get a cache hit. So then it will find the same error response that has been cached. And assuming the user B is requesting this in the time window that we stored this cache for. Now it will return the same error response from the cache to user B as well. So in this part, we've covered public CDNs, the architecture, the pillars of CDN, the pillars of the four pillars that are origin server, your CDN provider, your edge servers, and your DNS routing system. Further, we've talked about caching, what are the types of caching, the basic concepts, and the advanced techniques. Now, that we understand how content is stored and how it's served, the next part will focus on how we delete this content from the cache. So, I would like to allow Shutosh to take over now.
Okay. Thank you, Uma. So, hello guys, I'm Ashutosh and I'll be continuing. So, till now you have learned that in this previous session you've mastered the fundamentals of networking and understood how CDNs use edge servers to store the copies of the content. And now we will dive into the most critical part, that is the control of this cache. So, what we basically do here is let's start with the concept of cache purging. So, this is the foundation. So CDN caches store copies on edge servers to speed up the delivery. We saw this, right? That is what caching is. The duration of this cache is controlled by the HTTP headers, as we saw. And so this is what the HTTP headers controls look like. And we just saw that so here the deadline is of 24 hours, that is 86,400 seconds. So this system is great, but this system will work until it doesn't. And why is that? So suppose uh, you have uploaded some content and you've mentioned or you have defined the time to live expiry for it. And suppose you make some changes into the origin server uh, and that time to live is yet to expire. So the problem that arises here is that whenever an user tries to access the data, the user would get the stale data from the cache and he won't be able to see the updated data. So if we look into a real life problem that one would get is suppose you're on an e-commerce website and there are going to be new deals present and the admins update the data. But as the time to leave for the previous data was not yet expired, you may not be able to view the new deals that the admins had updated. So you must be thinking that yes, I understood the problem, but why is it necessary to address? So we come to these three main points that is the reason why we need to access the or assess this. So the first point is content freshness. So content freshness means to ensure that the latest data is visible immediately to the users. Second point is security, that is to immediately remove any vulnerable script or any malicious file that gets uploaded. Compliance is means to instantly take down any legally uh, or any policy that is being uh, non-compliant content, or suppose there is some violation of any policy. So purging is basically our emergency override for switching on global networks. Okay, so we saw why we need it. So now we'll see the what. That is what actually is content purging. So content purging is the explicit invalidation or removal of cached content from CDN before its TTL expires. So to sum up in simple words, we basically uh, so whenever there is any updates before the TTL expires, we would need to update the content that is being viewed by the user. The goal is to prevent the CDN from serving outdated cached content and force retrieval or revalidation of fresh data. So uh, we'll see this as we move on. Okay, purging versus invalidation. So what is purge? Hard purge is when the cached content is deleted from the edge storage. And soft purge is where content is marked stale and revalidated on the next request. So the example for this is whenever there are updates made in the content, there is a state where the cache has the previous data while the origin server has the updated data. And in this case, whenever the user would make a request, in the normal cases, the user would get the cache data, which is not updated. And to ensure that the user gets the proper data, we use purging. And in hard purge, the cache content needs to be deleted first from the edge storage, that is from the cache, and the fresh or the updated data needs to be accessed from the origin server. Whereas in soft purge, it is faster as we don't delete the data, but we make a new request directly to the origin servers, which skips the step of deleting and makes it easier to revalidate. Okay, we saw the why, we saw the what. Now let's see how it is done. So this is done using basically four methods. So the first method is the time-based or the time-based expiration. So the time-based expiration relies on the TTL headers from the HTTP headers. So we saw them. Can anyone answer me what actually was the main work of the expiry that we used to mention in the header? Okay, I see someone typing. To time, how much time to keep the data in the cache? Right. Yeah, that is the correct answer. And so this was to basically have the data in the cache for the specified time. So the main con in this was that this method must be override in emergencies. Suppose you updated some data that was not to be made visible to the users, and you in normal cases you would have to wait till the TTL expires, and in that condition it would lead to like major leaks, and it is not favorable for the organization. So to address this, we use different purging methods. So the next method would be manual or API purging. So this is direct or explicit instructions to the CDN to remove the content, wherein the CDN admins directly give instructions to the CDN to the CDN dashboards or APIs or CI/CD pipelines to remove the stale content and basically update the content. So the next method is cache busting URLs. In this method, we update. Okay, so the next method is the cache busting. This is an effective implicit versioning method, wherein the cache build busting updates the resource URL when content changes. Like for example, the best example for this would be for an e-commerce website. There are various assets like the CSS and the JavaScript file, which is used to display and uh, make changes to the content that is being visible on the website. And in cache busting URL method of purging, we basically uh, the we basically update the resources such that whenever there are changes made, uh, the content is basically referred as a new file. So suppose the original content was on the style.css file, and we made some updates, and instead of updating the each and every change that we have made, we basically tell the CDN to update a new file and to replace the previous one. So this is best for asset handled by the development pipeline, that is the CSS or the JS files. So the next one is the origin driven purging. So this is an automated explicit method for dynamic systems. Here, the origin-driven freshness controls the cache validity using the HTTP headers, revalidation, or version URLs, and not manual purchase. So we use tools like one of the tools is Webhooks, which is an automated alert sent from the origin to the CDN upon a publish event. So you might get a doubt that what is an publish event. So publish event is basically suppose a event is basically when you would say an update is made or some changes need to be made according to a certain condition that is met. So you might think that this is similar to what we have seen in the earlier case, but it is not. The main difference between is that in API or manual method, we actually perform the updates in the uh, origin server and the edge servers, but in origin driven purging, the entire process is automated using tools such as webhooks. Okay. So, and the main advantage is of using the origin driven purging is you can tightly integrate any e-commerce platform with the CDN for real-time freshness. So, taking an example of a e-commerce website, origin-driven purging might look like if there is any product that is on an offer and the product has gone out of stock. So the product going out of stock would trigger an event which would lead to the product being updated as unavailable for the general user to access. So these were the four types of purging that are used to basically handle the issues related to caching. So has everyone understood whatever has condition, whatever I have taken up till now? So can anyone just revise or tell the name all of the four methods that we have seen right now? See some people typing. Okay, I will also summarize all of the four methods using a simple analogy of an e-commerce website. So suppose you're using a website like Flipkart or Amazon or any other websites. So the time-based purging in these conditions would be, for example, when you visit the website, what are some of the things that usually don't change? That would be the uh, images of the products or the name of the website and in general GUI of the website. These are some of the things that don't usually change on a frequent basis. So these might be updated using a time-based expiration. So the next would be manual or API purging. So this is explicit, that is for critical or surgical fixes. In e-commerce, an admin would remove a single product listing with an illegal price, or if suppose the product was found to be having some defaults or having some faults, or the production might have stopped. In those cases, the product needs to be taken down from the website, and in those cases, an API purge or a manual purge could be taken up. for cache busting URLs uh, on the website. So suppose the main JavaScript bundle for the checkout uses version file names to force the users to download the fresh code instantly after a deploy. So suppose there are some changes made in the JavaScript related to checkout that we need to update. So instead of updating the individual changes in the JavaScript file, we provide the entire new JavaScript file, which would basically allow us to quickly uh, change it to the updated data. And for the last, that is the origin driven purging, we we could tell that suppose there is a major cell on the website that ends exactly at midnight, and there is this the inventory system that the system that handles the number of products on a website, the number of orders that are coming in. It would include a trigger to the webhook, that is the tool, which would notify to the CDN, and it would lead to instantly purging the cached version of the today's deal at midnight. So this would be the main applications of each of the purging method in CDN. So does anyone have any doubt regarding all of the content, any of the content that was presented right now? If you have any doubt, feel free to ask in the chat. Okay, seems like no one has any questions or any doubts. So I would just sum up this session by saying that effective caching is a layered strategy where you maximize your time to leave, and which in turn gives maximizes your performance, and also you would require to master the purging processes methods to ensure instant updates on your projects whenever it is necessary. So that was it from my side. Uh, and I would like to uh, conclude the session, and I'm happy to take any of the questions that you might have. Okay, so Neil has a doubt. In origin-driven purging, how does the origin request for purging? Okay, so in origin-driven purging, the main thing, how are those triggered? Okay, so the tool that I had mentioned, one of it is webhooks. You can set up certain conditions or set up those triggers, like if any order or if any product has a certain stock and it is over, so that would be integrated in the tool as a trigger, and whenever the condition is met, the request or uh, the update request is sent to the origin server. Yes, you are.